Thanks everyone for letting me present today. Hopefully next time I'll be able to come up and visit you in Brisbane. Um, yeah, I'm stuck in Melbourne at the moment. But today I'm going to talk about some of my adventures in Jetpack Compose, especially with animations. So if you're like me, you don't really have time for animations. When you're working for a client and you're trying to get your actual functional code working, yeah, the animations just get pushed to the back of the backlog. It's something we want to spend time on, but we never actually get there. And often it just ends up a nice to have, and then before you know it, it's off the list. So I was thinking to myself, animations always look like they're, a big task. So I wanted to try and make some time for animations so that I would spend time on them and know how to do them. So when I need to do it for an app that I'm working on, it's quick and easy to implement. So it was something I sort of decided to learn and do a bit of a deep dive into. So when I was starting to learn about Jetpack Compose, this was also when I started to play about animations. And I did a bit of a experimentation into different animation versions. So I was looking at the view-based system with object animator set, and motion layout. And I also tried a few Jetpack Compose animations. You can see from my little example on the right, some are more successful than others. In some of them, the little card I was playing with was sliding off the screen, which it wasn't really supposed to. So just a little context about what you're seeing there. You may wonder to yourself, what are these little cards and why am I flipping them over? Well, a bit of a confession is I'm a massive nerd. And as well as being a software engineer, I like board games a lot. And so I was making an app for a game that I like to play called Welcome to the Moon. Excuse me. And this involves flipping a lot of cards. And I thought it would be fun to make an app to make the game more enjoyable. So that's why we've got these cards with weird symbols on them. It's a great game. You should check it out if you like board games. So if you've looked at Jetpack Compose animation, you may have seen this flowchart. It's quite complicated, but it is trying to help you work out which animation API to use when you're trying to create some animations for Jetpack Compose. Initially, when I was going to prepare this talk, I thought I'd take you through all of the different types of these animations. And then I worked out that talk would be about 3 hours long. So we're not going to do that. Instead, I'm going to take you through two different types. So target-based animation and animated visibility. And these are two types that I think would be fairly, in a lot of apps and fairly complete to describe. Some of these other ones are still a little bit new to me. So the first one I'm going to talk about is the target-based animation. And for this, I'm going to make this animation on the right here, a card sliding across to the right and then flipping over. Pretty straightforward. So how do we go about building this? So for a basic layout, I've got my stack, which is just representing my two piles of cards. I've got a view model, setting some data in there. I have the cards on the left, the number stack, and the cards on the right, the action stack. And then my current card, the card that is going to do the flipping. Then I have a stack layout composable. This has some slots where it takes in that flipping card. It takes in a composable to represent the number stack and one to represent the action stack. Putting these in these sort of slots means that we can abstract out the actual display of the cards and we can worry about how they're displayed elsewhere and just worry about the animations for this one. So let's look into the stack layout. As I said, it takes in the slots. And for my basic layout, I'm going to use a row. So this is just to align the cards next to each other. We have a box, which for the moment is just going to have my number stack, the stack on the left, and the card that is going to do all the flipping just laying over the top of it, just for the moment. And then we have the action stack on the right. So this is a standard layout. Zero animation, as we click the button, the data just changes. So the user can't really tell that this is actually the card flipping over. There's no visual cues to let them know that that's what's happening. They still get the most accurate data, but they don't necessarily know what's going on. So we want to use a custom layout to animate this position rather than the row. If you haven't looked at a custom layout before, I'll take you through what it involves. So we have a layout composable, and this takes in some content. This takes in my number stack and the action stack and the card that's going to do the flipping. As you can see, there's no positioning here. There's no row to lay the cards side by side. It's just putting them in the view. No position, no sizing at all. Here, in this lambda, we then calculate the sizing and the positioning. The first thing we need to do is find each of these cards, each of these layouts. And we do this by using the measurables and finding it by the layout ID. This is pretty much exactly the same way that we would do it with find view by ID in the old view-based system. This is just the composed way of doing it. This can be actually quite powerful. If you give the same layout ID to multiple different things, you can actually get a list of components, and that's quite good to play with. So now that I've found each of the things I want to place, I then have this layout method here. So this takes in the maximum width and the maximum height of my composable. I then do a bit of maths here. So I've got the card width. So I'm calculating this based on the view to make this layout flexible so I can reuse it in lots of different places. So I calculate this width based on half of the actual view minus some card spacing. I set up the card width and height. And then I work out the X coordinate of where I want to place these cards. So the number stack, the one on the left, is going to be at position 0. And the action stack, the one on the right, will have an X coordinate of halfway through the view with a Y coordinate of 0. So that we can see how they'll be laid next to each other. And then again, for the moment, my flipping card is just going to lay on top of the number stack. Now that I have those coordinates, I can place them using the coordinates with the Y component being 0 for all of them. So now I want to start the animation. So I want to slide the card from left to right. It's the first part. So to do this, we have a state, which is my offset. And this is going to be a number from 0 to 1, which will slide the card between the left to halfway through the view. We can't use the final X coordinate because at this point, we don't actually know what that is. So we need to use a floating point value like a percentage between 0 and 1. You'll see how that gets used in a moment. So to do the animation, we need to use a launched effect. Inside this launched effect, we call the Animate API, and this is the target-based animation. This takes our initial value of 0 to our target value of 1 using an animation spec, which is what controls the speed of the animation. And this sets the value to our state. You'll also see the transition trigger. So this, every time this value changes, it will reset our launched effect back to the start. So it means it will reset our initial value of our Animate API. We pass this into our layout, and so this value is actually going to be the position in the stack. So as the user flips over cards, this value will keep increasing. So every time the user flips a card, the animation will restart again. We then use this offset value, the state that we calculated before, to calculate our X coordinate. We do this by multiplying the center value by the offset, and thus getting that continuous position between 0 and 1, the continuous position between the left side of the view to halfway through the view. You can play around with the maths for this, but it's pretty straightforward. And then we use this to place it. Now the cards will slide from side to side. That's pretty good. Animation's there, it's nice and smooth, looks good. And as the data changes, the card does look like it flips over, but it's still, we don't get that nice flipping action. So to flip it, we need to have a rotation. So we're going to, again, remember a state starting from 0, but this rotation is going to go between 0 and 180 degrees to represent the card flipping over in the y-axis. Again, we're using the target-based animation API. I'm going between 0 to 180 degrees in this case, again with the same animation spec. I could change animation specs here for different speeds or different configurations if I wanted to, but for the moment I've just used the same one. And this sets the flip rotation. So again, we have a bit more maths and interesting things here to do this translation. We use a graphics layer modifier. So this one, we can set the rotation in the y-axis to our flip rotation. So this means as the card flips over, we'll see the other side. To see that other side, because the cards don't really have two sides in our one-dimensional app space, two-dimensional app space, as the card passes that 90-degree mark, we change to the other side. Just using that same composable, I made it so that I could just change the values to show the other side. So as it passes that side, we show the back side. You may notice this camera distance part of the graphics layer here. This is interesting to play with if you're playing with animations that involve rotations or translations. It's where the camera is positioned when that graphics change is done. And this zooms the camera out and it allows the transformation in the composable to extend beyond bounds of the composable. You'll just have to trust me with my 8 times density number here. It's something to play around with and just experiment depending on your view and what your application is to see what works for you. But it's quite an interesting thing to play around with. If you don't have this value, for example, your composable will be cut off as it's rotating. So now I've got the flip. So as this comes across, it flips, and you can see how it extends a bit beyond the bounds of the composable, which is that camera distance. So if we have a look at this, do we notice anything that's going slightly wrong? As every time it flips over, you can see the graphic kind of changes to the other side. There's a bit of a mirror image thing going on. You look at this purple one, yes, flips over. So we've got a problem. It's reversing. What's happening here is as the card passes that 90-degree part, we're actually showing the mirror image. And this is because we're rotating around a central point. So the left side of the card becomes the right side of the card. This one was a little bit hard to play around with and work out what was going on. But what exactly I have to do is, in the actual card display, reverse it back the other way after we pass that 90-degree point, so that the left side remains on the left and the right remains on the right. Again, this will depend on your application, but it's something to play around with if you are doing things in the rotational space. So now we're done with flipping our card. But if you're watching my graphics carefully, and I'm not sure how good the internet connection is to see it, but you'll notice that in some of my frames, there's a bit of an issue. That there seems to be a bit of a flash. What's going on here? So if we have a look at what's going on when we do an animation like this, if we've got a view that has no animation, we take in the initial state values and then we just do the layout. All good. If we add in the animation, we read the state, then we calculate and animate value based on that initial state, and then we do our layout. This animate calculation actually goes to the next state. So we read it again and we do our layout. This is all good. Calculate the animation value again, pass that to the next frame, read the state, and do the layout. But what happens when the user presses the flip button? We get new data in the transition trigger. This comes across and resets our Animate API in our launched effect. But our state is still being read from the previous frame. This causes a problem because as that data changes, we've still got the old data there when we display it. So what we need to do is reset the remember states when the data changes, so that both the launched effect and the initial state of the animation reset at the same time rather than the next frame. So we can do this by adding the transition trigger to our remember method here. That way they're all set to the same thing. So when the data changes on all of them, they'll all be set to the initial value. So in our flowchart here, the user presses the flip button. We get the new data in our transition trigger. This comes across and resets both of them at the same time. You'll see that we now have the new state for reading, and then we can do our layout, calculate our next frame of animation, and then read the new state again. You'll notice that the calculated value from the previous frame before the button is pressed gets lost, but that's okay. We don't really care about it because we've already moved on to the next piece of data. So finally, my cards look good. Flipping over, there's no extra flash, everything's facing the right way, all good. And I can even do as many as I want. Because I made this flexible, I can just keep adding these in. I could even go up to 100, although I think the device might have struggle with this. I know my emulator was struggling with 3 cards here. But we can even interrupt the animation and it will start again at the start because we're keying everything into the transition trigger and not waiting for the animation to complete. So if you got really eager with this game, you could keep pressing the flip button and speed through it really quickly, no matter what part of the animation you have done. So the next thing I'm going to talk about is some dialogue animations. And this is using animated visibility. So I have this simple dialogue on the right, which just lets the user reshuffle the stacks or end the game. Pretty straightforward. If we have a usual dialogue, it just appears and disappears. There's no animation there, nothing special, just appear and disappear. But I want something a bit more special. I want it to expand and contract. Looks much more cool, much more fun, and could go really much more nicely with my app. So how do we go about doing this? So the first thing is to create a standard dialogue component. So we've just got a state to show whether to display the dialogue or not, the end game value for me. If it's true, we display the dialogue. And then we have in our onDismiss request lambda, we just have, we set the value to false to hide the dialogue again. In our dialogue, this onDismiss request gets added to the, gets sent to the default dialogue composable. So this means that when the user presses the back button or presses the grey screen behind the dialogue, the dismiss request method will get run as well and the dialogue will close. I also have some buttons in here that do some actions and then they dismiss the dialogue as well, using that onDismiss request method as well. So I want to make this a bit reusable because I'm expecting to have multiple dialogues for my application. And so I want to use the same animation for all of them. So I don't want to just build this in one spot and then have to copy it to other spots. So I'm going to create an animated transition dialogue. This will take in that onDismiss request, like the other one I had before, and we'll take the content of the dialogue. So I can just replace that content to make it easy. We're using that standard dialogue, just copying it from the previous version. That gets past the onDismiss request. We've got a box in there, and then our content. This is the animated transition dialogue. Inside of there is the actual dialogue, and then the content. And inside of there is the button. So now I want to define the animation, again, to make this reusable. So I'm going to use another function called an animated scale-in transition. This takes in a visibility boolean to show whether to make it visible or not visible, and takes in the content. This uses the animated visibility API. This also takes in that visibility boolean and takes in an enter and exit transition. I'm using scale in and scale out. This takes in an animation spec. Again, similar to before, this just controls the speed of the animation, which I set to just a static time. This also takes in the content. At the time of writing this, I think it actually might be stable now, but it was still experimental, the scale in and scale out transitions here. So I needed to use the opt-in here. So now I want to trigger this scale in and scale out animation. And I can do this via a coroutine. So I have my animate trigger. In this case, it's a Boolean. And then we have a launched effect again. And this time we're just keying this to the unit value because we just want to run this transition every time the dialogue displays. We don't need to restart the animation again. Every time the dialogue gets added, it's added new again, and we can launch the effect. So inside of here, we have our coroutine, and then we have a delay. And you might wonder what this delay is for. So there's an interesting thing with the composables is they do take a bit of time to lay out. And the trouble is that with this animation, we don't want our layout to occur while the animation has already started. We want our animation to start when the layout is complete. Now, this is usually only in the orders of a couple of milliseconds, especially for a very simple dialogue like mine. If you have something much more complicated, you will want to have that delay there. I probably don't need it for my little dialogue, but it's worth checking out anyway. And if you are testing this out, make sure you run your app in the release mode to try it, because when we're in debug mode, there's usually much more of a longer time for the composable laying out. And that's because we're collecting debug information for things like the layout inspector and other parts of emulators in Android Studio and other inspections. So you will see things speed up a lot, especially when working with animations when you look at them with the release build. But still, it's worth having that delay in there so you make sure that your layout is complete before you start displaying it. And this is something it's like 300 milliseconds. It's something very tiny. Once we know the dialogue has been created, and just so you know, there's no callback when a composable has been laid out. I did look to see if there was one. There isn't. I think that's potentially on purpose from the designers of the language, because you could get into quite a bit of problems if you've got a lot of call outs or callbacks from composables. So once this dialogue's laid out after our delay, we then set our animate value to true. So we start the animation. Inside our dialogue, we have our transition. So this puts the content inside of that animated scale in transition composable, so that the content itself will scale in and scale out. So now our dialogue expands. So when the dialogue, you can't even see it, it's still open, it just has a size of 0. And then we gradually scale out to a size of 100%. So now I want to do the scale out on dismiss. And this is kind of optional because it depends on your use case. For me, the user's not going to change screen after they've closed the dialogue, so I wanted to have that scale out. If in your use case, the user transitions to another screen or closes the app, you don't really need that scale out. So I wouldn't bother going to that extent. But I decided to. So to do this, I need a suspend function. And this is going to start this dismiss with that animation. We take in our animate trigger and that dismiss request that we were using before. We set the value to false. This is while the dialogue is still at 100% size. Then we need to have a delay again. This one gives the time for the animation to run. So it's set to the same value as our animation time. When the dialogue size gets to 0, we then call the dismiss request. So the dialogue is actually closed after it is at 0% size. And as I mentioned, this is a suspend function. So this needs to be run in a coroutine to make sure this is run all in order with everything else. So we need to register our coroutine scope and pass that into our dialog on dismiss request. So we launch the coroutine and run the start dismiss with the exit animation inside of there. We can then call this in we can then pass this into our animated transition dialog and our reusable one. But the trouble is that when we use any button inside the dialog content, this calls just the regular dismiss request. It doesn't call our coroutine because it doesn't know about it. How do we make that work? So what's happening here is we have our button in the middle of the dialog, and this needs to communicate with the dismiss animation trigger, which is sitting way up in the animated transition dialog. So how do we communicate? We can do this with a shared flow. So what we need to do is emit a value from the button to the shared flow, and then collect the value up in the dismiss animation trigger area. So to do this, I've created an animated transition dialog helper. I did get a lot of long names here. And this will do the admission to the shared flow. So we need to pass in the shared flow into my helper. We do the request dismiss from the button into the helper, and then this will collect the value. And then do this dismiss. So to do this, we need to make sure that our content is aware of the helper. So we pass it in as an argument. We create the onDismiss shared flow within our dialog composable. Then into our transition function and our content, we pass in the helper with our coroutine scope and the dismiss shared flow. The helper consists of our coroutine scope and the dismiss flow, a method that triggers the animation, launches the coroutine, and then emits to the flow. For this one, we just can emit any value. Just the fact that something's been emitted is enough for us to trigger the dismissal, we don't need to have any particular value here. But you could admit other values if you need to do other things. Then our animated transition dialog can use the dialog helper so that whenever we have the button, we can use this trigger animate dismiss dialog value from the dialog helper. Then back in our animate transition dialog, we collect the value from the shared flow and we can start the exit animation. So now the dialog expands and collapses. So here's some useful links that I was using when I was working on this. The official docs are always a place to go. There's also a few other Medium posts that inspired some of my animations. I also wrote a few blog posts when I was working on this without these pretty pictures in them, but if you want to check them out, you can. They're on my Medium page, and there's also some sample code there as well if you want to give this a try yourself. Thanks very much. Any questions?
Thanks, Katie. Any questions? Yeah. How do we determine the delay time for building dialogue?
Purely by trial and error. I just played around with a few values. I didn't really need it that much, as I mentioned, but just give it a try. If you are finding that your view doesn't, your composable isn't ready when you start the animation, it should be only in the order of 100 or 200 milliseconds.
Does that change much going between debug and release?
It does, surprisingly. I didn't know about it until I gave this talk elsewhere, and then there was a Googler in the audience, and he actually prompted him to write a blog post about how there is a difference. So I don't have that link here. Ben Traingrove on Medium, if you have a look up his name, he wrote a blog post about it. It surprisingly does. I mean, it was a case of a couple of milliseconds, but it's much less noticeable if I don't have that delay in there. But again, my dialogue is very simple. If you had something that had a lot more content, it would take a lot longer to lay out.
Are there any big animation libraries that could help with more complex animations, or is it going to be sort of by hand sort of stuff most of the time?
I haven't really used any yet, but Jetpack Compose is still relatively new. So I think some of those really well-featured ones that we used to have for the view-based system haven't really come to the fore yet. I think I've seen a few that have been in development, but there's no one special one that I've been using yet. And I've been kind of trying to explore it on my own. So I kind of like rolling my own and seeing how it actually works rather than trusting someone else's code.